Now, looking at the measurement of density and relative density, number one, we'll be looking at a body that can sink in water. So under a body that can sink in water, we'll be looking at the measurement of regular solid. Let's look at regular solid. Regular solid. Okay, the density. Now, we should know that the density of a regular solid is obtained by measuring its mass. We can use this with a spring balance or with a spring balance. Measure the mass, and we also measure the volume. The volume is determined by measuring its dimension. By measuring its dimension. Okay, that makes it good. I'm in the lab. I think I should have one of the balance. I'm coming. Give me 1 minute. Now this is a triple beam balance. Now what first is there's actually a line here. There's actually a zero line here. You can see that line there. Okay. Now whatever thing I put there, I'll make sure that I'm going to align these things to the end. Align this to the end. So whatever I'm going to make sure that this is one of the things we use this in chemistry. We also use this in physics to measure the substance. So a triple beam balance, or we could also use that instrument somewhere. You could also use a digital balance to measure things. You understand? To measure irregular, we just place it there, and that helps us. That helps us out, the mass. And how do we determine volume of water? This is water. This is water. Now, how do we measure the volume of the water? What we just need to do is, okay, I'm coming. Now, in measuring the volume of the water, we could decide to pour this water into, this is a measuring cylinder. This is a measuring cylinder, or we could use a beaker. Okay, this is what we can use. We use a measuring cylinder. We could also use a beaker to measure the volume of water. So what you just need to do is, remember, water does not have a shape. Water does not have a shape. It does not have a shape. So it takes the shape of the container. So all you just need to do is pour the water. You can see if it stays in this calibration, 200. All right. This one also. So either you use this or you can use this. Take the measurement of the volume of water. Okay, so how do you get the density? If you have gotten the mass, of the solid, you want to measure using a beam balance, a triple beam balance. Okay, if you've gotten the measurement of this gives you the mass. Okay, the water using measuring cylinder or beaker gives you the volume. So how will you get density now? Density is mass over volume. So you just get the mass divided by the volume. That gives you the density. You understand that part?
Yes, sir.
Okay. Now, how do we? Okay. Number 2. Let's look at the measurement of irregular solid. Irregular solid. An example of irregular solid is a solid that has different shape or that does not really have a shape. Okay, a piece of stone, like a stone. How do we measure a stone? Number 1, what we do first is this. The mass of the regular solid now the mass is obtained as for regular solid. But what do we do is that the volume is measured by, we immerse that stone in water. Remember, we take the measurement of this water. We take the measurement of this water first. Now, if probably if this water was measurement of this water was 200, when we place a stone, do you think the volume will increase or decrease?
Increase.
It will increase definitely. So when we take the measurement of this 200, when we put a stone, it increased to 250. All right. So the volume of the stone will become 250 minus 200. All right. Okay. And that gives us 50. So that means the volume of that stone was 50. Do you understand that? Do you understand that, please?
Yes, sir.
Okay, so the volume of the stone will become 50 because the volume of the water was 200. Now, when we added the stone, it became 50, it became 250. Now, the volume of the stone becomes 250 minus 200, and that gives us 50. Now, we know we can always get the mass of the stone using our beam balance, and that gives us the density. Density becomes mass over volume. All right, that is for irregular solid. Now, another thing else we must consider is okay. Another thing else we will look. We could also look at other types, other ways of that's density, relative density. Okay, with this now, we can start some calculations. Let's do some calculations. Okay, number one, a body weighs 0.30 newtons. A body weighs 0.30 newton in air. Body weighs 0.30 newton in air, 0.25 newton when fully immersed in water, when fully immersed in water, and 0.27 newton when fully immersed in a liquid. When fully immersed in a liquid. Calculate A, its loss in weight in water. Its loss in weight in water. B, its relative density. And C, the relative density of the liquid. Okay. Can you try it?
Yes.
Okay. Try, please. Wow, that's a good one. But one is correct. Why not use the other method of since you were giving weight in Newton, why not use weight in air over weight of equal volume in water? Do you understand?
Okay, sir. Yes, sir.
Okay, because if you're looking for density now, that means if you're using density, it has to be mass over volume. We don't have the volume here, and even though we can get Newton in mass, but we don't have the volume. All right, so it would be wise to use the other formula, which is weight in air over weight of equal volume in water. Since you have the weight, and you can calculate the weight in water, you can calculate. You've calculated the loss of weight in water already. So that can be done. So you can use that formula rather. All right, so you can do that then.
Mass of equal volume of water.
Mass of over mass of equal volume of water. Okay. What would be your mass of substance then? Does that mean you
Zero
want,
point
want to convert the
three zero Newton.
you want to convert the Newton to mass? Is that what you wanted to do?
Yes.
Okay. Well, I would really like to explore and see what it will give you, but okay. Let's explore then. Okay, you can continue, please. You can continue. Looking at, since they said the body weighs an equal amount in a particular amount in air, another amount in water. Okay, if I were to do that, I was going to use um that's the weight in air divided by the weight of equal volume in water. But what you are using is still the same thing. You can still use that. I like being dynamic. I like your dynamic nature. If you're using the mass of substance in air over mass of equal volume in water, you will still get the same answer. So I want you to try what you're doing, and I'm going to show you my own method also. So we'll compare and contrast them. Let's look at the third question. Okay, could you do the third one up here? Do this up here. Which you are seeing there, that's 0.27. Remember, it's actually the weight of the liquid and the weight of the water. So if you are using 0.27 as the relative density of the liquid, it's not going to work because we are having two things inside the liquid now, but we are looking for just the relative density of the liquid. So that means we have to find the density, the upthrust of the liquid first, of the liquid, then upthrust of the upthrust when it's in water. So for us to get the upthrust of the liquid, that would be the weight of the body minus the weight in water. That gives you weight of the liquid. I mean the upthrust in the liquid, isn't it?
Yes.
Okay. So that's actually what we do. So just work it out. Understand what I said, right?
Yes.
Okay. Now, actually, what I said is this: for us to calculate the relative density of the liquid, what we must understand is this: relative densities would be the upthrust of the liquid over the upthrust in water. When we are talking about relative density, we are talking about the density of that substance or divided by the density of the equal volume of that substance in water, or sometimes we call the upthrust in liquid over the upthrust of equal volume in water, or it could be the mass of a substance or the mass of equal volume in water. Now, in this case, they said in the liquid, now the body weighs 0.30 in air and 0.27 when fully immersed in water. Now, the relative density of the liquid, we are going to use the formula for relative density. Please, I don't know if I gave you three formulas of relative density, but if I didn't give you, please note the first formula. The first formula for relative density, number one, is the mass of substance over the mass of equal volume in water. The mass of a substance divided by the mass of equal volume in water. That's number one. Number two is the density of a substance divided by the density of water. The density of a substance divided by the density of water. And number two is the upthrust in liquid divided by the upthrust in water. The upthrust in liquid divided by the upthrust in water. Okay, now for us to get upthrust, remember, upthrust is actually one weight of substance minus the weight of another liquid, probably. Now, but they said this body weighs in air. Now, this body came to water and weighed another amount. Remember, I told you that when we come to water, our weight decreases. Our weight decreases. So now this body, when it got to water, when the body was out of water, it was 0.3. Now this body came into water and started weighing 0.27. Now, what you're expected to do is this. If they said if the formula for this is if the formula for this is upthrust in liquid, that means what we are meant to do is we are meant to find the upthrust of this body. We are meant to find the upthrust of this body in the upthrust of this body in the liquid. But that 0.27 was actually the weight of the body and the weight in water. So you're having two conflicting things there. What we just need to do now is this. To find the upthrust in liquid, that becomes the weight of the body minus the weight of that body in water. That will give us the upthrust in that liquid. That will give us the loss in weight in liquid. That will be the upthrust in liquid divided by the upthrust in water. You have calculated the upthrust in water, which is the weight in air minus the weight in water. So the relative density becomes the upthrust in liquid divided by the upthrust in water. Do you understand? Do you understand now?
Yes.
Okay, please work it. Can you work it out now?
Yes.
Okay. Now, this is awesome. This is beautiful. I really like this. Now, this is a very nice one. Let's continue. Let's continue now. Let's solve another. A metal block 900 kilogram per meter cube. A metal block of density 9,000 kilogram per meter cube weighs 60 Newton in air. Weighs 60 Newton in air. Find its weight when it is immersed in a paraffin wax. Find its weight when it is immersed in paraffin wax. Find its weight when it is immersed in paraffin wax of density 800 kilogram per meter cube. Take G to be equals to 10 meter per second. Okay, with this now, can you try that? Can you check
Yes, sir.
now? Hello?
Yes, sir. Yes, sir.
Can you?